last time we analyzed something like this was way back at the beginning, where James Webb Telescope released a couple of images, and one specific image analyzed a specific exoplanet a couple of light years away from Earth. And this exoplanet was actually critical because they were able to analyze and determine through absorption of light and detecting various wavelengths that indeed there were particles present in that exoplanet's atmosphere. And this here is translated into this particular new images of another exoplanet that they've been investigating for a while. But this particular group of scientists from UC Santa Cruz is really fantastic to see what they're able to accomplish in terms of the same style, but with one interesting new discovery. This discovery is really fantastic according to this article, which says that Webb telescope makes first unequivocal detection of carbon dioxide in an exoplanet's atmosphere. Now, this is a huge game changer because according to this article, we have a couple of atmospheres with presence of pretty much light elements. We're talking about nitrogen, we have oxygen. Those are pretty much elemental particles that are quite light. However, when it comes to heavier particles, the power of this James Webb telescope is really surprising in a good way, because now we can detect carbon dioxide, which is classified according to this article a heavy element. Technically it's not an element, it's kind of a compound, but we're going to go with that. So it's really fantastic in here to see this accomplished, and most importantly, the same method that we used to determine water presence in that particular atmosphere on a different exoplanet. This particular technology was done in here. We're going to look at the data this video. I'm going to dive more into how they were able to come across this particular result. In terms of the location of this exoplanet, it is a Saturn-like mass planet that is called WASP 39b, and this actually orbits really close to a sun-like star that is around 700 light years away from Earth. Now, this is located at the constellation Virgo, and it's also more than 20 times closer to its star than Earth is to the star, in this case the sun, and about the same mass as Saturn. It is less dense and about 50% larger, probably due to the heating from being so close to the sun. That is why it's considered to be a little bit lighter or less dense than that of our Saturn that's close to our solar system, that is in our solar system. Now, previous observations have said that this particular exoplanet atmosphere is pretty much clear, and it's really easy for transmission spectrometry to be performed through this particular James Webb telescope's instrument analysis here. Now, is this discovery the best and the first of its kind? Not really, because they said that there were hints of this particular carbon dioxide presence in this exoplanet from past data from Hubble telescope and also Spitzer telescope. And so it's really nice to see that this particular telescope, James Webb telescope, is not only able to give the concrete result, but most importantly give raw data as to how much or the levels of carbon dioxide that is present in that atmosphere in this particular exoplanet. Now, if you're thinking of carbon dioxide in our solar system in terms of the planets, there are other planets in our solar system that has carbon dioxide, either coming from Mars to Venus, as well as gas giants like Jupiter and Saturn. Now, in terms of how the importance of this carbon dioxide is with respect to our atmosphere or any atmosphere in any of those planets, it all comes down to what are the other content that carbon dioxide can be transformed into in terms of the build of that particular planet. And that thinking is what they are going to be using in terms of analyzing this particular exoplanet here, that is WASP 39b. I cannot find this particular article fascinating in terms of classifying carbon dioxide as metallic based on what analysts are calling it because of how heavy it is relative to the likes of hydrogen and helium. But still, it can be a misconception, because you don't want to classify it as metal, because of course it's not metal. However, because it's considered heavier, they're kind of making the equivalencies with the metallic nature of how heavy it is relative to other gases that are found in majority of planets that are considered light and really easy to detect. However, in terms of carbon dioxide here, is actually really sensitive in terms of the measuring stick, according to this particular analyst here. And so it's really fascinating to see the classification of carbon dioxide relative to other gases in the atmosphere, and also how heavy it is compared to other gas particles in the atmosphere. Now, another interesting terminology here is called transiting exoplanet. And what does that mean? This means here that when you have a specific planet that is moving in front of a specific sun, and you're viewing that particular planet from Earth, that particular planet that is in front of its sun is known as transiting exoplanet. And so by so doing, that planet is going to be absorbing the sun's light, that is its sunlight, and therefore when we detect it, in this case James Webb Telescope, is going to have a dip in its graph, as we see right over here. And so through this analysis, according to the relative brightness, we can now see how they can use the near infrared spectrograph, in this case from the James Webb Telescope, to show the change in brightness, which is shown here in terms of the 3 different wavelength colors of light, according to the WST 36 star system over time, as the planet transited the star on June 10, 2022. And this dip is going to be shown as you go from sunlight to sunlight blocked by the planet and its atmosphere, and then back up again. Now, the critical part here that is focused here is the dip here. And this dip, when you look closely, you see regions where planet's atmosphere blocks less of the color, of specifically the red color, and while on the other hand we have the planet's atmosphere blocks more of this color, which is in this case green, because of the absorption of carbon dioxide. And so this illustration here now gives us that particular final result in terms of the curve. And this curve is shown right over here in terms of how we can now see that at wavelength close to 4.3 to around 4.56, let's put it that way, there is a huge spike, and that huge spike indicates the amount of light that is blocked to be majority of it carbon dioxide. And so this is really wonderful to see in terms of how they're able to go from the blocking light amount in terms of starlight to specifically saying how carbon dioxide is reflected on that particular wavelength graph that is shown right here. Now, in conclusion, what are the next steps? The next steps here is that since we're able to detect carbon dioxide, we're going to look at how hopefully this is going to be compared to terrestrial planets that are exoplanets, and how this particular data stands out to those type of planets. Another thing that this particular article address is the similarities with that of Saturn, and it says that it has similarities with Saturn. Saturn metallicity is 10 times that of its sun, and whilst this particular planet here, exoplanet 39b, also has the same amount of heavy elements, about 10 times relative to its sun. So if that is the case, how about other types of exoplanets that is similar to this type of exoplanet in terms of its Saturn-like nature? Will they have that same amount of metallicity or amount of carbon dioxide relative to others? That is really a fantastic question to ask as we move into exploring more of this type of exoplanet, focusing on how James Webb is actually producing these fantastic results. So overall, I hope you found this video informative. Please hit the comment down below. Let me hear your thought about these 2 particular analyses in terms of, one, whether Saturn-like planets behave the same way in terms of that metallicity. Do you think that is the case, or do you think, nah, maybe we're going to see something that is an outlier? Or on the other hand, in terms of questions, do you think that there will be terrestrial exoplanets that will be able to foster this type of carbon dioxide nature that exoplanet that we just analyzed possesses? Jump down into the comment section and let me know your thoughts. All the same, thanks for watching. See you on the next video. Stay smart as always and believe in yourselves.